Hi, I am Sam. Thank you for listening and watching this talk in which I will present preliminary results and the concept behind a short postdoc which I did last year, funded by Fulbright and the BAEF at Pennsylvania State University with Christelle Wautier, where we looked at laboratory volcano geodesy and inverted magma-induced surface displacements in laboratory experiments. And one example of those experiments is shown below with its vertical displacement. And this is really what happens when magma breaches the surface. We get a volcanic eruption. But a major aim and question of volcanology and the subject of my work is what happens before that magma reaches the surface. How does it propagate? How does it deform the crust? And better formulating answers to those questions can help us better forecast volcanic eruptions in the end. And because we can't really look physically below the surface and directly observe that propagation mechanism, we lean on geophysical data. And here is again the 2014 intrusion in Iceland, where we could look at different data streams. And one of those is surface displacements, which are created when magma pushes its way towards the surface and displaces the host rock. And this surface displacement can be observed by satellite radar as well as GPS stations on the ground. And the example here is a map with colorful fringes that represent the displacement away or towards the satellite caused by the magma intrusion. Another way to look at the mechanism is through seismicity, where the earthquakes represent where the magma has broken or displaced host rock. And these are the black dots which you see on the second figure on the bottom. We can combine these independent data streams and run inversion models to try and estimate intrusion source characteristics. These include the depth of the intrusion, the geometry, the orientation, and the volume. However, these models assume in their standard form that the Earth's crust is responding elastically to that magma intrusion. And these models, this assumption is used standardly because it is the most straightforward to implement. It is the most simple the simplification which we can make of the process that allows rapid calculations that then become useful for eruption forecasting. When we look at geological observations, however, we very often see that more complex non-elastic deformation occurs as well. And the images here are illustrations from the Oslo Rift system, where we show in our paper published in G-Cubed in 2020 that both opening mode fracturing, so elastic deformation, and shear mode fracturing, so non-elastic deformation, have occurred there during emplacement of some dikelates. So the question really becomes how accurate these elastic inversion models are to estimate magma intrusion characteristics that are in those events that are dominantly non-elastic. How valid are our assumptions in that case? And to answer that question, we use laboratory experiments. And during my PhD, we characterized the mechanical behavior of the sand plaster mixtures we use as analog material to the Earth's crust. And our mechanical tests have demonstrated that those sand plaster mixtures have a brittle ductile behavior that is quite similar to the shallow crust, where as we increase the plaster content, we increase the strength of the materials, but we also transition from a brittle to a more ductile behavior. And this transition occurs as well as we increase the normal load on that material. and more details we will publish soon in a preprint and hopefully a submission to Tectonophysics. But so now we think to understand our model material behavior quite well. We developed a novel 4-dimensional laboratory monitoring method where we brought our sandbox to a medical X-ray computed tomography scanner. And this scanner visualizes the intrusion geometry, but also helps us to quantify the 3D displacement and strain fields during the intrusion of the golden syrup, which we use as a magma analog. More details of the technique are in our 2019 Frontiers paper. And what we can do using the X-ray CT is extract surface displacements like this one here. The yellow curve represents the final surface deformation caused by that red rendered golden syrup intrusion, which you see on the right of the screen. And this is a 2D profile, but we extracted data in 3D, both the vertical as the horizontal north, south, and east-west components. So what we can do now, since we have data that are similar to what we collect on active volcanoes, is run analytical models. And here we show the result of a simple forward model using an Okada tensile dislocation, which is basically a rectangle buried below the surface, and the rectile is opening in pure opening mode perpendicular to its plane. And this is what these are the parameters that visually fit best to our observed vertical surface displacements. You can see the residual error map there, and most parameters fit quite well between model and experiment, except for the horizontal length, which has to be half the size in the forward model as it is in the intrusion experiments, to fit the magnitude of vertical displacement quite well. And we will now use these forward model results to identify the interval of parameters that we will allow the inversion model to run to try to automatically find the best fit of the model parameters to what we know are to the observed surface displacement maps from the experiments. And we hope then to learn which parameters can be fit better or worse, and where really the limitations of the elastic analytical models lie compared to our experiments, which we know display non-elastic deformation. So these efforts have been delayed because of pandemic 2020, but I am still continuing those inversions now being back in Brussels. And we are also starting to look at the interaction between magma-induced and tectonic stress fields. But from the 1st of August 2021, I will be starting at the Space Research Center of the Polish Academy of Sciences in Poland, where I'll be working on Demo Planet, which is a project where we will model magma-induced deformation on terrestrial planetary bodies, and that will focus mainly on laccoliths. If you have questions about my research, then you're welcome to contact me at the below emails. I'm very happy to discuss more of it. Thank you very much.